Welcome back, guys, and it's been awesome to hear from you guys this week. Even if it is only virtually, it's been cool to read your discussion posts, to interact with those, and I love seeing all the comments and emails and all that kind of stuff. It's really made this a little bit easier, a little bit more fun to hear from you. We started off the week talking about ions, about how we make ions, what they are, which if you watched the other video, you know that ions are just atoms that have gained or lost electrons. Now, side note, they can also be particles, and we'll get to that a little bit later if you really want to go in depth with ions. But today we're going to talk about bonds and start to talk about how do we create more complicated things called molecules and compounds. So without any further ado, let's start with talking about a definition. That definition is going to be compound. So the word compound, basically what I mean by that is going to be a substance made up of two or more elements. So most of the things that we interact with on a day-to-day basis are made up of more than one thing. For example, even though a lot of us is made up of carbon, a lot of plants are made up of carbon, it's not just pure carbon. Instead, you have carbon mixing with hydrogen, mixing with oxygen, all of these things that are held together by something called chemical bonds. So that's kind of the big umbrella thing that we are talking about the next couple of weeks, our chemical bonds. How do we get these different elements together? And the best way to kind of open up this discussion is to think about how you interact with people on a day-to-day basis. We're social creatures, which is why this whole period of time is so jarring. It's so weird, right? Because we need interaction. Atoms also like to interact with each other in a way, but you interact with people differently based on your role in life, and atoms do the same thing. So there are three basic ways that we can have bonding, okay? So I'm going to kind of do this here, chemical bonds. We're only talking about one right now, but there are actually going to be three ways that we can bond our atoms together. The first one is going to be ionic. That's what we're talking about today. But you can also have covalent, and you can have metallic bonds. And again, you're still creating compounds. You're still creating something where you're putting elements together, right? You're getting elements and you're kind of working them in a way that now you're getting this crazy new thing that can do different things. But it's just the way that they interact, the way we put those ingredients together. That's where we get these three different terms here. So the best example that we can use when we're talking about ionic bonds is going to be salt, table salt, which a lot of you guys actually put in your discussion question. So table salt is actually the technical scientific term for it would be sodium chloride. Okay. So sodium chloride, we would write it like that. You have two ions that are interacting here. You have your sodium right here, and we have it in the name like that. And then we have chlorine. Now, I know what you're thinking, chlorine and chloride, basically what you do when you make terms, when you name these different compounds, you actually have rules that you use, kind of like how your name changes based on who's talking to you. For example, my name to my peers, my friends, they might call me by my first name. They'd be like, hey, Melissa Bailey, or maybe the full thing. But if you guys are talking to me, you guys say Mrs. Bailey. So based on the role, these different compounds have different names, right? So how does this happen? Well, let's look at the structure of both of these ions really quickly. So here are the board diagrams for both sodium over here, and chlorine over here. This is them not as ions. This is them just hanging out in their usual happy selves. Now, notice what's interesting about the outer shell, or what we would call, again, these are called valence shells. That's just the outermost energy level of these diagrams. Now, when I draw that like that, notice that sodium only has one little electron hanging on to the outside, whereas chlorine has an almost full shell over here. So what happens in this specific compound is this electron right here, okay, is going to actually move over here, which means, bada bing, now that we have, when that electron moves, so I just moved it, I drew it over here onto my chlorine atom, now I have two ions. I have sodium as a positive cation, and I have chlorine as a negative anion. Now, this is the beginnings of how we get our ionic bond. If you guys know where I'm headed with this, what happens if you are talking about circuits? What happens if you're talking about magnets? Opposites attract. Opposites attract. Yay. So, when opposites attract, positive here, negative here, we get salt, which is our sodium chloride. Now, what we find in table salt, we have our sodium and our chloride. They just kind of stack over and over and over again into a structure that we could call a lattice. So this right here kind of becomes a cube-like structure like so. So we call this, let me write it or type it for you, a lattice, okay? So in summary, this is going to be a short video because, again, most of this stuff was kind of making sure you understood what ions are. Once you know what ions are, it's easier to understand why they're attracted. It's just the simple reason that opposites attract. So what's happening here, if we're defining this relationship, as I try to move these things out of the way and talk at the same time, now it just says lat. Oh well. So what we find in relationships, right, there's some sort of give and take, and that's what we find in this sort of relationship. This is kind of like, let's say a friend that you lent something to. So for example, I have a neighbor that I lent a book to, and I have not seen that book since I lent it to her. And so I'm probably not going to get that book back. That's what's happening in ionic bonds. So if we were to give a technical definition, if you guys are taking notes, I would make sure you know this stuff. So ionic bonds are basically bonds between metals and non-metals in which electrons are transferred. So we're not sharing them. We're not like having this happy little thing. It's like one of them is giving them away and the other one is taking them. So let me bold that, transferred. That's going to be important later on. So electrons are transferred between one atom and then they're given to the other atom. If you look at the periodic table, and let me show you a picture of that really quick. Whoops, that's not it. So what you'll find with ionic compounds is that it's always going to be something from this side of your periodic table, and I really should make that bigger, something like that. So your metals, okay? And it's always going to have on the other side some of your non-metals, that yellow group right there, okay? Non-metals. So that's where we're going to find our ionic bonds. Yeah, that's all I got for you guys today. Quick and easy, hopefully. Again, feel free to pause the video, to rewind it, all of that good stuff so that you guys can make sure that you understand what's going on and there's not any questions. Also, feel free to send me an email if it just isn't clicking, if it's not making sense. I'm compiling a list of your questions from the Nearpod right now, so hopefully sometime tomorrow or at the latest Thursday, you'll have another video answering those questions and answering any other questions I get in between those two times. So it's good to hear from you guys, good to see you guys interacting with everything, and I hope that you guys are doing well. Miss you all. See you soon. Bye.